Welcome to the IoT podcast show. I'm your host, Tom White. Today I'm joined by Stephen Galsworthy. Stephen was the former Chief Data and Product Officer at Quby, an innovative Amsterdam startup business famous for its smart thermostat. And he joins us today to talk about data science in the IoT field. Stephen, welcome to the show.
Hey, thanks so much for having me here, Tom.
You're very welcome. Stephen, could we just kick off by you explaining a little bit more about yourself and your previous role, which I think our listeners are going to be most interested in, at Quby?
Yeah, certainly. I would describe myself as an analytical executive. I have a background in data science. I was a data scientist over 10 years ago before the terminology was widely in place. And over the last few years, I've sort of grown with that sort of data science, big data buzz in the field. I've sort of at the core, I've really been fascinated by innovation. I've always been really fascinated by using data, using mathematics to make insights and make new products and technologies. And artificial intelligence is something that really I'm passionate about. My last role was as Chief Data and Product Officer at Quby. That's an Amsterdam-based tech company. It was very well known for creating a smart thermostat that's sold across Europe, sometimes called the Tone or the Box thermostat, and was very active in that sort of IoT space. I came in around about 5 years ago now and kicked off sort of building up the data science capabilities from scratch. And what we've seen in the last few years is throughout Quby, data and data science has become essentially the core of the company. It's been the core of the strategy, and you've seen that shift from a hardware-focused organization into more of a software services and data-driven software services organization. That was where I wasn't until relatively recently. So your listeners get a full perspective. I mean, I'm originally from the UK. I studied a PhD at Oxford University, and I've now lived in the Netherlands for about the last 7 years now.
Yeah, fantastic. Thank you for that intro, Stephen. Yeah, of course. And so our listeners are aware, and not to embarrass you somewhat, Stephen, but your academic background is truly remarkable and fantastic. And you know, your pedigree in data science really is second to none. And I think it's useful to touch. You're very welcome. I don't want anything. I'm actually just saying it. I think so that people are aware, you know, data science and the manipulation and the understanding of the data that comes from IoT devices is absolutely 101 to the success of the device, and often can be somewhat overshadowed due to the functionality of what may be an IoT device, depending on what it is and what it's doing. So really interested to delve down more into that. So to kick things off for people that perhaps don't understand what data science is, can you just give a high-level overview of data science and its role that it plays within AI, artificial intelligence, please?
Yeah, certainly. I mean, there's a lot of buzzwords that fly around with big data, data science, AI, and how it all fits together is an interesting puzzle. So the way I look at it, it all starts from the data. So data is the information that you're collecting, for example, from IoT devices. Data science, what you're really wanting to do is you're wanting to use data of whatever form to understand something in more detail. This can be done via very simple, relatively simple analysis, or this can go all the way to using machine learning algorithms, deep learning algorithms, and to really understand that data. And then AI is a little bit more when things get a little bit more software heavy. So when you're actually wanting to perhaps deploy a product that has data and data science and these algorithms really at the core, that's when things are moving more towards AI. It's a little bit of a spectrum. There is no, I mean, you hear in the movies about what AI sort of killer robots coming on. I mean, I think we're a long way from that in reality. What I've seen the trends, particularly in data science in the last few years, has been sort of refining the field a little bit more. It's a little bit like 20 years ago we would refer to a lot of software engineers as programmers, and they would all just do programming stuff, and lots of people within businesses would not understand the details of that. Data science is seeing different kind of specializations arise from that as well, whether that's more focused on using data to make decisions within a business for business strategy purposes, or using machine learning and deploying that in sort of production workflows to enable completely new products.
Yeah, that's a great explanation for everyone that perhaps was a little bit uncertain on that. And it's interesting you should mention the difference between programming and engineering and development and what that means. And there are nuances between them, and I think that's an interesting comparison that you've made there. Going further to that, so how can we use data science and AI to extract additional value from IoT hardware, and why should we be concerned with this as well?
Yeah, I mean, I think we're seeing with the IoT sector in general, there's many billions of IoT devices out there in the field right now, and those devices are offering some kind of services, but there is a lot of untapped potential. There's many organizations that have collected probably petabytes or more of data, and that they've got these huge stores of data, or it's being collected in real time. And you can sort of sense this potential of something that you can do more from that. So IoT is really, I see it from the data science perspective, it's the source of data. What you have in the concept of AI, you have something that's known as the virtuous cycle of AI, which essentially is the idea that if you start with some data, it allows you to develop some algorithms. From that algorithm, you can develop a product or an experience that you're creating. Then you're going to get people using that product, which are then going to give you more data. That more data is going to allow you to create better algorithms, and those better algorithms are going to allow you to increase the experience and make that better for the existing users, or to get even more users. So you sort of end up spinning around this flywheel kind of setup. And you see the organizations that are really successful with that, I mean, particularly the large tech companies, have that very much built into the fabric of their organization. So I think what you can do there is, if you're using the IoT as this source of data, and you're also maybe a customer focused facing app that you can provide some insights or additional services, you can get into this flywheel and start offering additional services on top of. Maybe, I think a good example is perhaps a temperature sensor. There's many billions of temperature sensors that have been deployed across the world that are giving maybe a reading, maybe 1 second, maybe every 1 hour. That's giving a limited amount of information. What you could do is perhaps you could be uploading that data to the cloud, running algorithms that are detecting anomalies in that data, are able to form some kind of fingerprint of the system that it's monitoring, and be able to alert the owners of that system before something breaks down. This can be done as we've explored at Quby in domestic heating systems, but this can be done in large industrial processes, commercial processes, in many places.
Thank you. And you just touched on that. So you obviously did this at Quby. How did you accomplish this at Quby? So obviously the product, again, for people's benefit, was a smart thermostat. Company grew very, very quickly. Obviously, was then acquired by Eneco, wasn't it?
Eneco, yes.
Eneco.
Yeah, that's a large Dutch utility. Yeah.
Yeah. So did what it was accomplished, but how? What was the data science element there? What were you collecting and understanding from the smart thermostat?
Yes, so I think to give the viewers a little bit of insight, so the product itself was a touchscreen smart thermostat that was typically installed in the living room of a domestic home. It was connected to the central heating system, typically the gas boiler, and also had a connection to the electricity and gas meters. So it was able to not only control the heating system, but to see in real time how much energy was being consumed in the house. So you get a sort of obvious benefits for a customer of that. They're able to control their heating system using an app when they're not at home. And you can see perhaps historically a little bit of insight into how you're using energy. But what we were really seeing was there was a demand from customers wanting to explore a little bit of how they could save more energy, how they could avoid wasting energy. So I think the best way is to give an example. I mean, we created a product that was known as the waste checker within Quby. So this was taking that electricity and gas data that was flowing in from these electricity meters via the smart thermostat. The data was flowing into the cloud. We were then able to run various algorithms, some machine learning, deep learning algorithms, to extract from that data, so from electricity meter data that's coming in maybe every 10 seconds, and looking for patterns within that data to identify different appliances such as the washing machine or dishwasher running inside the house. From those detections, they were then able to build a fingerprint of appliances, so a way of understanding how those devices are operating on maybe a weekly or monthly basis, and then able to see how much energy those devices were consuming, and then to be able to give recommendations to the users. So for example, with a washing machine, you would perhaps be able to detect if a machine was 15 years old and just needed to be replaced. It was so old, so inefficient at heating up water that you should just replace it. Or it could be a washing machine that is where it's a brand new A++ machine, but the user is washing all of their clothes every time at 60 or 90 degrees, when they could get away with perhaps washing at 30 and get a similar cleaning power. So then able to offer personalized, targeted advice to those customers of how they can avoid wasting energy. So not focusing on real sort of energy savings. We found that the sort of the psychological trigger was to trigger people and saying, hey, why are you needlessly wasting energy? You can make this change and stop wasting energy. And that was very well received within our user base. And this went on to become one of our most popular features of the whole product.
Yeah, that's really interesting, isn't it? And the dynamic between not necessarily saving from an expenditure point of view, but saving from an environmental impact.
Exactly, yeah. I mean, depending on each individual, they have different drivers. For some customers, it really is that reducing the carbon footprint, making sure that they're using as little energy as possible. Others, there's more of a financial pressure. I have to say that there's somewhere it's just the challenge of being able to target and sort of the gamification aspect that comes in. And you need to have a combination of these different incentives to be able to make a product work across a very large user base.
Yeah. Yeah, no, absolutely. I think it's curious. I mean, did you ever? It's a slightly off the cuff question here, but did you ever get a privacy sort of question mark from any of the users about people identifying habits and things like that? Were anyone a little bit alarmed about that? Because obviously there's an altruistic type of view here, isn't there? Be that environmental or monetary, but
yeah, I mean the kind of data that these IoT devices installed in homes are able to collect is incredibly sensitive data. So that was always something that was very close to what we were doing, and we would always make sure to get the users to opt in for using that data for any secondary purposes, such as providing insight into their behavior. We found in general that users were willing to make that trade-off if they were willing to grant access to their data if they were getting something beneficial back for themselves. So if they're getting insight into their own appliances and their usage, and they can actually take actions based on that, they're willing to share the data. I mean, I think it would have been a different question if we were using the data for targeted advertising and showing flashing advertisements on their living room screen. So it really depends quite strongly upon the use case, and I think if you've got something that a user can see an immediate benefit from, then by and large people are willing to share data.
Yeah, absolutely. Yeah, it's interesting actually, isn't it? Because I mean, you came into Quby to really set up this data science practice. An interesting question might be, and for some of the people listening who own similar scale-up or startup businesses in IoT, what advice would you give to an IoT organization that wants to successfully implement an AI capacity through the understanding of data science, who haven't done it before necessarily?
Yeah, it's a good question. I mean, I think the first piece of advice I would give is don't go in with the aim of setting up AI. I mean, go in with the aim of making better products for your users. And at some point, if you come in with that customer-driven mindset, you will perhaps get to the level of complexity where you are needing to step into AI and machine learning. I think there's some key things that you can do there. I think a strong one is instilling sort of a real product-based mindset within the organization. So getting multidisciplinary teams in place that are only satisfied with their job when a product is released to market, and the users of that product are happy with that product, and it is solving those users' problems. I think to enable that, I mean, what you're really wanting to do is to have sort of leadership that is able to make that link between the business part of the business focus and the technology focus, and to have translation at various different levels. I think everywhere from the boardroom downwards, you should have this link between the business and technology. And I think what we're seeing, particularly with AI, is that it is quite complicated right now. I think we're seeing a sort of a new generation of leadership that are coming in that perhaps have a little bit more of that technology background, that data science background, are not able to make that translation between the data, the business, the technology, the products, and put that all together into something that's productized, that can sell, that can add user value. I think if you're really looking for, one piece of advice, if I'd be giving to an organization that's serious about going with AI, is to really target getting labeled data. So from a data science perspective, this is data that you can use to train machine learning algorithms. You maybe as an organization already have access to a huge amount of data, but probably a lot of that is relatively useless for actually training models. So in the Quby context, this would be knowing when someone in a home was turned on their washing machine. So you could compare the detections you take from your smart meter data with the detection with the truth, and then you can actually iteratively train algorithms. So for organizations that are serious about taking those next steps, I always encourage them to think a little bit ahead of what kind of training data they might require, because it takes a bit of time to set this up. You're probably talking in terms of perhaps doing a pilot project or something like that, where you're explicitly going with the goal of acquiring training data. This may not give direct business or organizational benefits within the next 6 months, but in 2 years' time, you're going to really thank yourselves for that.
Yeah, thank you. It's so interesting that you started that out by saying what is the benefit to the customer, to the user, right? The first thing that you said was beyond AI. How can this improve the customers? And that's a beautiful mindset to have, because ultimately, from a business perspective, that's what you should be looking at. I also noticed as you were answering that question, it was very similar to the principles here in the UK that we have on the revised Data Protection Act of 1998, right? Mm-hmm. So data should be just, it should be relevant, it should be held with the right reasons, and you're saying that the principles of the understanding of that data will help program ML based upon the collection of the useful data that we have, and not just collecting it for the sake of it. Am I right in saying so?
Exactly. I think that the trends, particularly in the last 5 years or so, have been collecting as much data as you can, organizing that, storing that. We're now shifting into the realm of using that data to add value, whether that's through analytics of making better business decisions, or real sort of AI engineering of deploying new products. And I think the trends we're going to see in the coming 5 years are a lot more focused on what's the right data we need to collect, how do we refresh and maintain that data, and how do we use that data to actually make product impact, which is ultimately end user impact, helping people solve their problems.
Yeah, absolutely. And that leads me on really nicely, actually, to my next and final question, Stephen. So, you mentioned the next 5 years. Where is this going? What can we realistically expect to see? I mean, clearly you mentioned killer robots. Hopefully we don't have any of those too soon. I mean, the world's had enough on its plate for the last 18 months. But where's this going from a data science perspective? I'd be curious to hear your thoughts.
Yeah, I mean, I strongly believe that artificial intelligence is going to be the defining technology of the next decade. In the same way that we saw the internet come and change the way that many businesses are operating, I think we're going to see a similar impact with artificial intelligence. I think successful companies, the ones that we're going to look at in 10 years' time, are going to be the ones that have managed to deploy artificial intelligence and integrate that into their core business operations. In the same way that we see the leaders in their fields right now of were some of the first to act on the internet. So take Amazon, for example. It's a great example of a company that started off as being an online bookseller, now into doing, just about everything under the sun. I think the state of AI right now, things are pretty dumb. There's a lot of talk. Self-driving cars is a great example of that. I mean, I think we're taking various steps to get there. But there's an awful lot of work that needs to be done to handle various edge cases required that you'd want for the confidence levels of handing over control of your car to a computer for every single road condition. I think in the business, there's a term that's being used a little bit more now. It's called amplified intelligence. So using artificial intelligence not to hand over control to robots and let them make all of the decisions, but using that to improve human making decisions and the ability of humans to create better products. I like to compare it a lot to tools we've seen, like something as ubiquitous as Excel. I mean, years ago, spreadsheets existed. They were a manual process for accountants, and it would take a long time. You'd need very special training to be able to work with this. Now, I mean, everyone can use Excel for better or for worse. And you're seeing this as an enabling tool. I anticipate a similar level of democratization of AI. I think we'll see machine learning become embedded into existing tools. I think we will see the machine learning tab of Excel be strongly used for making predictions over the coming years. And I don't think you're going to need to be an expert. I don't think you need to be a data scientist to benefit from using some of that. I think in addition to that, you're going to see that sort of data science realm that is going to shift a lot more into being a core part of software engineering. I think you're going to see the majority of software products that will be released in 10 years' time will have some degree of machine learning embedded within them, and the intricacies that need to be taken into account when developing a machine learning product as opposed to a typical software need to be taken into account. One example of that is the fact that if you've got an algorithm that is training on data, if the code stays the same but the data changes, the end result can change still. So you need to be aware of things like drift in the data, and this can have a huge impact on the accuracy of the algorithms, but ultimately the impact that those products will have for the people using them.
Yeah, fantastic insights. I love the phrase amplified intelligence as well.
Yeah, I'm a big fan of it.
Yeah, I think it certainly makes sense. I think from my perspective, sometimes the most logical solution isn't always the right one. and that will be interesting to see how we cope with that moving forward and what that looks like. But I completely agree with you.
I mean, I think it's going to be very interesting to see how artificial intelligence is used in decision making within businesses. I mean, are we going to end up at some point in the future where we have a sort of a robot sitting in the boardroom that is going to come back with it's almost like the Mr. Spock kind of input. You want to see, okay, is that logical or not? I don't see a time when we're going to hand over control of the CEO of our companies becoming a computer and everyone is responding to them. I think there's always going to be the human aspect needed, and that translation into what that means for people and their ways of working, ambitions and motivations.
Yeah, a good friend of mine, actually, Amsterdam-based expat, was very much into big, unsolved, meaningful problems, and I think it's a very interesting thing that you've mentioned there, because you don't necessarily want a robot answering this in a boardroom. And also, if you look at the World Economic Forum and they talk about the future of jobs and the problem-solving element, this is something that is going to be more and more apparent. And who is best to answer that, and how do we get to the point where AI and ML can help influence a decision, and so on. So lots of questions.
Yeah, I mean, I think it's going to be really an enabling tool, and it's going to come. Any tool like that can be used for good or can be used for bad, and I think it's really going to be the role of the humans in the mix there to make sure artificial intelligence is being used as much for good as possible.
What a perfect way to end it. Stephen, thank you so much for coming on to the show. It's been absolutely great hearing your insights. I've really looked forward to this. Where can our listeners find out more about you? You've got a website, right? They can log on to your website?
Yeah, I've recently kicked off stephengalsworthy.com, where I shared you can find there my links to LinkedIn page, Twitter, and various other talks and articles I've been giving recently.
Stephen, thank you so much for joining us here on the show today. And if you'd like to find out more about data science in the IoT industry, have a look at the link in the comments below to Stephen's website, stephengalsworthy.com. Get involved in the conversation. As usual, you can subscribe to our newsletter at theiotpodcast.com, and we look forward to seeing you on the next episode.